Hey there, ever feel like numbers have their own secret language? Well, today we're going to crack the code. You'd be amazed at the simple patterns hidden in the numbers you use every single day. So let's dive right in.
Okay, let's jump right in with a little challenge. Look at this number, 351. Now, here's the question. Is it divisible by 9? Without leaving a remainder? Oh, and no cheating. Put that calculator away.
So what if I told you that you could figure that out in like 5 seconds? Seriously, it sounds like a magic trick, I know, but stick with me. By the end of this, you're going to know the secret.
But before we can pull back the curtain on the trick, we have to go back to basics. We've got to understand the fundamental building blocks of numbers themselves. This is where the real story starts.
All right, first up, the factor. So what is it? A factor is just a number that divides another number exactly, with nothing left over, no remainder. Think of them like a number's DNA, the core pieces that make it up.
Let's make this super clear with an example. Take the number 6. What divides into it perfectly? Well, 1 goes into it, so does 2, and 3, and of course, 6 itself. So 1, 2, 3, and 6, those are the factors of 6. That's it. That's its complete set of building blocks.
Okay, so that's factors. Now let's look at the other side of the coin, multiples. It's a really simple idea. If factors are about breaking a number down, multiples are all about building it up. A multiple is just the result you get when you multiply a number by any whole number.
So for a number like 3, what are its multiples? Easy. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9, and you can just keep going forever. It's like this ever-expanding family of numbers, and that's a huge difference from factors, right? That list actually has an end.
Okay, so let's put these two head to head. Factors, they divide a number, there's only a certain amount of them, and they're always smaller or equal to the number. Multiples, they're the product of a number, the list goes on forever, and they're always bigger or equal to the number. See? Total opposites, but completely connected. Getting this difference is absolutely crucial.
All right, you got the basics down. Now this is where it starts to get really cool. What happens when we take two different numbers and see what they have in common? This is all about finding that common ground. And that brings us to something called the greatest common divisor, or GCD for short. It's exactly what it sounds like. It's the largest factor that two numbers share. Think of it like finding the biggest piece of shared DNA between them. Now check this out. This is a really slick way to find the GCD. Let's take 12 and 18. What's a factor they both share? 2, right? So divide them both by 2, and you get 6 and 9. Okay, now what about 6 and 9? They share a factor of 3. So we divide by 3, and we're left with 2 and 3. Now, those don't share any more factors. So what do? We just multiply the factors we pulled out, the 2 and the 3. And boom, 2 times 3 is 6. That's your GCD.
Okay, so that's the GCD. Now for the other side of things, the least common multiple, or LCM. I like this analogy. If the GCD is about their shared past, the LCM is about the very first time their paths will meet in the future. It's the smallest multiple that both numbers share.
And we can use a really similar trick to find it. Let's try it for 18 and 30. First, we pull out a 2. That leaves us with 9 and 15. Then we can pull out a 3, which leaves us with 3 and 5. Now, for the LCM, it's a little different. You multiply all the numbers on the outside, the 2, the 3, and the leftover 3 and 5. You multiply that whole chain together, and you get 90. That's it. 90 is the very first number that's a multiple of both 18 and 30.
Okay, so we've got our tool belt, we know factors, multiples, GCD, LCM, we're ready. It's time to go back to that first question, that number, 351. Let's finally reveal the secret.
And here it is, the big payoff. These are the number shortcuts, the divisibility rules. Now, scan down to the rule for 9. What does it say? The sum of the digits is a multiple of 9. Okay, let's go back to our mystery number 351. Let's add up the digits. 3 plus 5 plus 1 equals 9. And is 9 a multiple of 9? Yeah. So there's your answer. A big, definite yes. 351 is divisible by 9. That's the whole trick.
But here's the most important part. This isn't actually magic, not at all. It's just a really cool pattern that comes from the way our entire number system works.
Every single one of these rules is just a clever shortcut that's built on the idea of factors, the very thing we just talked about. So you didn't just learn a trick, you actually learned the math behind it.
And trust me, this stuff isn't just for showing off at parties. These concepts, factors, multiples, all of it, they're literally everywhere. They're like the invisible architecture that holds our world together.
You know, this whole idea of building blocks takes us to a really special, almost famous type of number, the prime number. A prime is a number whose only factors are 1 and itself. That's it. It's like you can't break it down any further. Primes are the true atoms of the number world.
And what's so wild is that every other whole number is either a prime itself, or it can be made by multiplying a unique set of primes together. It's a fundamental truth of math. And that's why they're so important for everything from the cycles we see in nature to the encryption that keeps your information safe online. Seriously, prime numbers are a whole other universe of secrets.
So you see, factors and multiples, they aren't just math terms you have to memorize. They're a new way to see the world, a lens to spot the hidden patterns all around us. Now that you know the basics of the code, what other secrets are you going to find hidden in the numbers you see every day?